Before we dive into different types, let's revisit the core technology itself. At its heart, a blockchain is a special kind of database, a digital ledger. Think of it as a chain of tamper-evident digital blocks. Each block contains a list of transactions, and once added to the chain, it's cryptographically sealed to the one before it. This creates an unchangeable record of history, a concept known as immutability.
Now, let's explore our first type using our analogy of the public web. This is a public blockchain. It is permissionless, meaning absolutely anyone on Earth with an internet connection can join the network, view its entire history, and participate in validating transactions. There is no CEO, no central administrator. Control is completely decentralized among all its users. This radical openness is built on three pillars. First, decentralization. Power is distributed, making the network resilient and free from single points of failure. Second, transparency. Every transaction is recorded on the public ledger for all to see. And third, immutability. The cryptographic structure ensures that once data is recorded, it cannot be altered. These pillars create a trustless system. But with millions of anonymous users, a critical question arises. How does everyone agree on the state of the ledger without a boss to make the final call? This is solved by consensus mechanisms. These are the rules that govern how the network achieves agreement. Let's look at the two most famous examples. The first and most famous method is proof of work, the engine behind Bitcoin. In this system, network participants, called miners, compete to solve an incredibly complex mathematical puzzle. The first miner to solve it gets to add the next block to the chain and is rewarded. This computational effort is the work that secures the network, making it extremely difficult and expensive to attack. The other major method is proof of stake, used by networks like Ethereum. Instead of a computational race, participants called validators lock up or stake their own cryptocurrency as collateral. The network then randomly selects a validator to create the next block. If they act dishonestly, they lose their stake. This economic incentive is what secures the network, and it's far more energy efficient than proof of work. The most prominent examples of public blockchains are, of course, Bitcoin and Ethereum. Bitcoin pioneered the space as a decentralized, peer-to-peer digital currency. Ethereum expanded on this by introducing smart contracts, self-executing code on the blockchain, which transformed it into a global, programmable platform for building decentralized applications, or dApps. However, this open and permissionless design comes with significant trade-offs. Public blockchains often struggle with scalability, leading to slow transaction times and high fees during peak demand. Furthermore, while identities are pseudonymous, the complete transparency means there is limited privacy. These challenges make them unsuitable for many business applications, which leads us to our next category. Now, let's step into that secure corporate intranet from our analogy. This is a private blockchain. Unlike public chains, these are permissioned networks. An entity must be explicitly invited and granted rights to join, read, or write to the ledger. Control is centralized, typically held by a single organization that acts as the gatekeeper. The core features of a private blockchain revolve around control and efficiency. First, permissioned access. A central authority manages identities and dictates who can do what. Second, enhanced privacy. Data visibility is granular. You can configure the network so that only the parties involved in a transaction can see its details. This is a crucial feature for businesses handling sensitive information. Because all participants are known and trusted, private blockchains don't need slow, energy-intensive consensus like proof of work. They use much faster algorithms where a few trusted nodes validate transactions. This results in dramatically higher transaction speeds and massive scalability, capable of handling the high-volume demands of a large enterprise. In the enterprise world, leading private blockchain platforms include Hyperledger Fabric and R3 Corda. Hyperledger Fabric is a modular framework used by companies like Walmart for supply chain management, allowing them to track products from farm to shelf. R3 Corda is purpose-built for the financial industry, enabling secure and private transactions between regulated institutions. However, the centralized control that provides these benefits also introduces weaknesses. Private blockchains are not trustless. You are explicitly trusting the organization that controls the network. This creates centralization risks, as a malicious or incompetent operator could potentially alter records or censor transactions, defeating one of the core philosophies of blockchain. So we have the open, decentralized world of public blockchains and the closed, efficient world of private ones. Let's place them side by side for a direct comparison across the most important attributes to make their distinct DNA crystal clear. This clear divide between public and private raises an important question. Must we choose between decentralization and performance? What if an organization needs both? This leads us to the middle ground, consortium and hybrid blockchains, which aim to combine the best of both worlds. First, let's look at a consortium blockchain. Think of this as a semi-private blockchain. Instead of being controlled by a single company, it's governed by a pre-selected group of organizations. For example, a group of banks might run a consortium chain for interbank settlements. It's more decentralized than a private chain, but still permissioned and not open to the public. Next, we have the hybrid blockchain, which offers even more flexibility. This model combines a private, permissioned blockchain with a public, permissionless one. Companies can run their operations on a private chain for speed and confidentiality, but periodically anchor or notarize transaction data onto a public chain. This provides a publicly verifiable, immutable timestamp without exposing the sensitive details. Now that we understand all four types, let's map them to real-world use cases. Public blockchains are ideal for applications requiring extreme censorship resistance, like cryptocurrencies and public voting systems. Private chains excel in supply chain management and internal asset tracking. Consortiums are perfect for interbank settlements, and hybrid models are emerging for digital identity and healthcare records. So, how do you choose the right architecture? It comes down to three critical questions. First, who needs to participate? Is it open to everyone or a select group? Second, what is the trust model? Do you need a fully trustless system, or are participants known and trusted? And third, what are your performance and privacy requirements? Answering these will guide you to the optimal solution. Let's bring it all together. Public blockchains offer unparalleled decentralization and censorship resistance. Private blockchains deliver enterprise-grade performance and confidentiality. Consortium and hybrid models provide a flexible middle ground, blending elements of both to solve specific business problems. There is no single best blockchain, only the right tool for the job. Understanding this spectrum, from fully public to fully private, is essential for anyone looking to navigate the future of business, finance, and digital collaboration. The conversation is no longer about if we should use blockchain, but which blockchain architecture is right for the problem we're trying to solve. Thank you for joining us on this deep dive.